Welcome to Transform Now, a podcast focused on intelligent automation and brought to you by SS&C Blue Prism. On this program, we talk about how organizations globally are rethinking the way they operate, utilizing process orchestration and AI-enabled digital workers to free up humans to do the work that matters most. We also share insights and tips on how you can embrace this new way of working and unleash your full potential. Let's get into the show.
Hello, everyone. I'm Michel Marchuk. Welcome to the Transform Now podcast. Our guest on this episode is Rotem Alaluf. Rotem is the founder and CEO of Wand.ai, a generative AI platform that brings personalized interaction using natural language with corporate data to the business users. We'll be exploring how these interactions work, as well as how organizations can protect their data while getting the most out of Gen AI. So welcome, Rotem. I'm so glad you're here with us today.
Thanks a lot, and great to be here.
So you're no newcomer when it comes to working with business-focused AI. I mean, from Beyond Minds, which is a company you founded about deep learning and AI research, now to Wand.ai, you've always taken a result-oriented approach to adopting AI. So tell us a little bit more about your background and how your ideas were formed to get to this Wand.ai concept.
Sure. From background perspective, I'm working in the AI field for more than the last decade, focusing on building large-scale systems in AI that are able to create real-world value, starting in defense and intelligence, and then moving actually as an entrepreneur that I started multiple companies. And I'll say that I'm trying and focusing on how we are bridging the gap between things that are working for demos or in the lab and proof of concepts in very large-scale systems that can help billions of people to create immense value. And I think that the opportunity currently, which we just see at the very beginning of it, in moving everything to natural language interaction, is a completely new way to interact with computers. So if until today, we needed to learn computer languages, today we teach computers to speak our language. And eventually the goal is to enable agents or AI systems to do everything that people can do with technology by themselves. So you'll be able just to ask something, and instead of have a teams of dozens or hundreds or thousands of people for some tasks to do it, agents collaboratively with us will be able to perform those tasks and execute them. So we are looking at human-machine collaboration at a very strategic level, how we are bringing two types of intelligence together in order to achieve what we were never thought that is feasible. And we believe that this is like the biggest revolution that humanity will create when it will happen. So we don't know exactly when we'll get those intelligence level, if it's 5 years or 10 years from now, but we'll do that. And that will be probably the biggest achievement in human history. Of course, everyone is passionate about creating that, and in the company and outside in the AI community. And I think that we are in a very exciting times.
I would definitely agree. Do you think this transition was it really spurred on by the whole OpenAI release of their 3.0, ChatGPT 3.0 large language model? Because we've had AI for quite a long time, but is that kind of the turning point?
So I think that OpenAI did a very nice job in showing everyone how AI can be used by the masses, how it can be helpful to perform at the beginning very simple tasks using ChatGPT in that part, that it shows how simple it can be. And it probably ignited the way that people are thinking about the technology. If before, like everyone thought, yeah, it's very like techy, very complex to use the technology. We need to have a PhD in computer science in order to do that. I think that's the biggest transition, because technology-wise, the transition wasn't that big between the technologies we have before ChatGPT and ChatGPT. The technology leap wasn't that huge. So it was a combination of avalanche of marketing part and a bit better technology. And this marketing part got to the very non-technical users. And I think that's the amazing thing that happened, that at the end, technology needs to serve not the PhDs that are creating it. but the everyday users, everyday enterprise users, or if it's B2C, every user eventually. And I think that's the magic that happened there. And yes, this is actually ignite and accelerated development of the technology to places of doing things that are much more sophisticated than just answering very straightforward questions that are knowledge based, to the areas of automations, to the areas of planning, to the areas of steering these types of technology in order to do and execute much more complex tasks. And we are still at the very beginning of this journey, but it looks more and more promising every day that we are dealing with the technology. And everyone has a lot of bottlenecks also that we are trying to solve, but we are every day we are able to do more and more complex things using intelligent systems. Generative AI is one cube and one component in those intelligent system, compounded intelligent system. Like our brain is not one component. So we are building those systems, and every day we are able to see that they are doing a bit more sophisticated things. And
Yeah.
of course, our goal is to get to a situation that those systems with a very high level command from a person can run automatically and do those things. So if today we are asking questions about fix a text and phrase it nicely, or give an example for a go-to-market plan, in the future we'll be able to say things like optimize my revenues or execute the go-to-market plan periodically. And just like agents will run and do it for us. And it will open actually an area that a very small amount of people, together with dozens of thousands of agents, will be able to build a very significant operation in a very low cost.
So you mentioned a couple of things in there. One was you talked about automation and the concepts that are behind that. You also described, how our brain, this is working on our brain, and our bodies are carrying out commands for our brain. And coming from the more traditional RPA side, SS&C Blue Prism grew up in that arms and legs phase where we were executing based on a sort of rules-based automation that brought activities forward. Now that we have these large language models, which, as you mentioned, they're very good at managing text and kind of done it in an encapsulated way. When you marry those two together, what do you see happening as we move forward? Is this the way that things like these intelligent agents or whatever are going to come to life?
Yeah, so I'll say that the way that we are looking at this intelligent system, intelligent agent architecture is one, we are using large language model mostly for pulling data and doing a very small segments of a complex task. This is something that they are able to do. But then we need a steering mechanism. The steering mechanism can be in very specific tasks, also like a rule-based system. If you have very specific like process, but if we're looking at a more generalized process, they need to be a bit different. So there are multiple families of AI fields that can deal with those problems, from the reinforcement learning and a lot others, that can help actually to build a steering mechanism in a way that will help to steer the large language model in order to achieve even dynamic goals. If we are looking at the human brain in that part, so we have the part that is responsible for language, we have the part that is responsible more for the planning and steering. And today with large language model, you can think about us as the planner or the one that is steering the large language model in order to achieve a more complex goals. So you can use large language model today in order to achieve complex goals if you are there and will give them multiple instructions and you will combine all the dots. The thing is that possibly we can also replace the human there in most of the phases with a steering mechanism that is different than large language model that will enable us to get to a similar output. So our goal is to enable the human to move to more higher level commands to those systems, meaning that we need a steering mechanism that will replace the human in the process today technology. Another thing that is highly important of those intelligent systems, if we are trying to create them to work in a similar way that we are working in that part, is the topic of personalization. So how they are understanding one, what we wanted, if it's like something that is specific for us. So you and me has different preferences, maybe an output. You'll say, yeah, it's a great output. And I'll say, nah, I don't like it. It's not like the style I like to see a go-to-market plan. And you'll say, it's great. I really like it. And it's possible. So those parts, actually, how agents are interacting and adapting themselves to the human that they are interacting with. And this is something dynamic, right? I can interact with you differently than I will interact with someone else. As a human agent, I'm adapting my personality a bit when I'm interacting with different people. And we want to create a similar mechanism for AI agents in this process.
That
And
makes sense. That makes a lot of sense, especially when you start talking about the way that we interact with things now. And we know that when we go over to our microwave or whatever, we know how to interact with it because these are very defined interface. But it's the same thing that applies with people. You mentioned you talk with a child differently than you talk with an adult, right? You're adapting the way you're speaking to be able to convey the information or to execute something. When you're working with a digital workforce that has agents as your interface and you're speaking language to them, you may need to change the way you speak, just like you change the way you speak to a child versus an adult to be able to get that information across. Do you see that as being something that is we call these prompt engineering kind of concepts, but do you see this as sort of a skill set that employees will have to take on, is how best to talk with these digital workers?
First of all, prompt engineering is a very trivial and naive approach to
I know.
create.
I thought that's the only context I have to be able to ask that type of
But that's
question.
what like most companies are using today. But it's very naive way. That's not how our personalization is working exactly. Like we are
Hmm.
not prompting it differently, but we understand actually the scenarios and the environment that we are at, and there is some kind of multiplications between this environment and our general personality that created an adapted personality that is working well in this environment. And this mechanism that we are seeing in humans. And this is something that we're trying to imitate also for agents. For the questions about what people need to do, our goal is to make agents indistinguishable from people in the process. So I don't want you to say, okay, I'm speaking with an AI. I need to speak differently in this process. We want to make it seamlessly for you. And eventually, those agents will have the persona. So also, if you're speaking with me and someone else a bit differently, so you'll speak also with agents a bit differently, but we want to make it indistinguishable from humans in that part. So you'll speak with one agent in one way and with another agent in another way, like you're speaking with humans in the same approach. So when we'll create intelligence and we have a journey to get there, there is no reason why it won't have its own characteristic, its own personality, and will just work together in a synergy in order to achieve tasks. There will be things that this intelligence will do better than us already, like it's 100x faster in achieving a lot of tasks from us, or thousands x faster sometimes. And there are things that it will be worse than us at the beginning. Hopefully, sometimes because the evolution of AI agents and intelligence, or artificial intelligence in that part, is faster, uh, potentially we can get to superhuman intelligence in most aspects in the coming years. But at least there will be some gray area that will be better in some, and the other intelligence will be much better in some aspects that will be able actually together, when we work together, we'll be able to achieve a huge amount of value. So again, we are trying to make this technology indistinguishable for us when we are discussing with a human agent or an AI agent.
Gotcha. So you mentioned something related to when you're doing that, we're speaking and the AI agents will have a contextual understanding so that we won't necessarily have to prompt them very specifically because they will understand the context in which we're speaking to them. What was interesting to me though is as you were talking about that, taking that context and and it can be scary to have folks say, if all this AI is going to be doing our work for us, what are we good for? The reality is that you mentioned before about the planning, the task planning, that kind of thing is as part of the overall still requires a purpose, right? There needs to be a purpose behind why we're doing these things. Just because they can be done more quickly, the humans still have to direct it, which then I think brings it up even to more of a strategic level in terms of how businesses are operating, what markets they go after, which customer bases they would want to target or serve as part of their overall. You go into the government space, how are we managing our specific demographics from that perspective? So those are purpose led kind of discussions that you can then bring into a contextually aware AI who can then perhaps be much more effective at the tasks and planning, but there's still a purpose that humans would be able to provide to them. Is that kind of the idea behind it?
Yeah, so the way that we are looking at it is how low level you need to go with your request compared to how you're able to provide a very, very high level purpose and still it will be executed. So sometimes after you have a very nice idea, you'll tell yourself, okay, now I need to decompose it to a lot of pieces in order for a technology to be able to deal with each piece in that part. Our goal is to take it every time one step forward, that you will need to decompose it a lot less and less until you'll be able to give the original purpose, like the really raw idea that you have to a system, and it will create everything end to end for you. But it will take time to get to the level. But we are focusing on how humans and machines are collaborating and not how machines are replacing people in that part. We want to do everything a lot more productive and to enable every person, even if he doesn't have the technical skills, to be able to execute very complex technical things today using agents. What we will expect to see is a lot more businesses that are started by smaller amount of people. So the amount of people that will work will be similar according to the amount of people in the workforce, but we'll see a lot less workforce in each business and a lot more businesses that will be able to run almost automatically with the purpose in mind of the people by the agents.
Gotcha. That makes sense to me because I see that kind of natural transition happening. But one of the things that I guess most folks are concerned about is as you're building these things out and generative AI is both learning, but also understanding some of this more contextual viewpoints, there's specific ethical use questions and biases that come into mind. How can businesses protect their output from these biases? Or is there a potential to allow bias to enter into it, which would be beneficial for that output? Because not all bias is wrong.
First of all, two main points about biases. Systems are biased according to the information they got. Very similar to people, right? If you grown up in a specific environment, you will be biased with specific culture or specific religious. You'll be biased towards something specific more than others that grown up in a different environment. So AI systems in general are similar in that part, and they are biased according to the data that we are providing to them. So this is like one of the first topics that need to be discussed and also regulated in the best way. What data actually AI systems are trained on in order to make sure that it align with some general norms of humanity that we want to proceed. After we train the AI systems on biased data that we've created, by the way, as humanity in the part, so we can put guardrails, but they are a bit artificial guardrails all the time because the system is biased already, but we are trying to protect it from pushing its bias to outside. the best thing is to solve the root cause of the problem as much as possible. So that's about that part. Second, one of the things that transformer-based large language model or autoregressive large language models in that part are not good at is critical think. In general, transformer-based system doesn't know what they don't know in that part. So if you take a large language model and you say, solve a math problem, he will completely hallucinate because he doesn't know that he's not good at math. It's just a probabilistic model that is trying to push the next token, and it's creating most of the time a sentence that makes sense, but it doesn't know that it's very bad at this topic in general. And we are seeing it over and over again. I'm dealing with large language model in the last 6-7 years that are transformer-based systems. And I don't think that we got a lot of improvement in the part that the systems eventually can't reason and can't plan and can't understand what they don't know in that part. So this is required, as I mentioned before, another system that will steer the large language model and will know when to send things to a large language model. Let's assume that you have a Python executor and you have a math problem. It's much better to calculate it in the Python executor than like to ask the large language model to do that, because he doesn't know how to do that in a very similar way that, yes, you can try to solve a very complex math problem in your head currently. And probably, maybe if it will be complex enough, probably you will get the answer wrong. But you can use a calculator also, and probably it will be right. So also which tools and when to use a large language model and how to steer actually the agent in order to use different agents. One is like an expert in math and using Python, and one is expert in knowledge and using large language model, and one is expert in report generation and will use LaTeX, or doesn't matter which tool. The steering mechanism is crucial in order to reduce significantly the hallucination problem that we are seeing in large language model, because we won't use them when we don't need to use them. But again, the steering mechanism needs to know which tool knows what, and large language model doesn't know when they don't know something. So I have a litmus test I'm doing like for the last 7 years with large language model with a very simple math question that every human is solving in 5 seconds. Non-model is still able, and every 4 years old or 6 years old kid can solve. No model from the very original transformer-based architecture or built after that to GPT-4 Turbo and Cloud 3 Opus can solve this simple problem, which requires only like a very, very simple planning and understanding what you don't know to do. So this is actually why we need actually a more compounded system and not only a large language model in order to create those intelligence agents.
That makes a lot of sense to me. And when you start building out these larger ecosystems of AI and other systems that can support them building it out, you run into two things. One is there's the assumption that it should be able to do everything, because look how amazing it can do this one very specific thing. You mentioned with large language models being very good at one specific thing, and then the general public gets enamored thinking that it can do everything.
Yep.
But bringing apart this ecosystem, which includes multiple tools that are good at specific things, allocating work amongst other systems, executing or bringing data in. These are all components that as you fit them together into that ecosystem, now you can have that more comprehensive plan that executes and then delivers on the business outcome as you go through, with over top of that, humans who are provided the purpose for that whole ecosystem to both exist and to execute as it's going. But it also sounds really complex. How can we get from this idea of bringing the magic AI altogether to the reality of where it's a bunch of components that we have to push
Yep.
together to make that happen?
So first of all, like this is something like at Wand that we are doing. Actually, we are building those intelligence systems that are compounded as a system by themselves. And they also have a system of other agents. You can call them tools, but we are calling them other agents. And as you have probably in your phone someone that is expert in Python, and if you have a question, you'll call him like, how I'm solving that, I'm stuck here. Also, the agent should be able to do that. They will be able to contact some of the agents that they are in touch with in network and interact with them in order to solve problems that they are not experts in. But for that, as I mentioned before, they need to understand that they are not experts in this problem first. And this is something that transformer-based systems are not great in doing. So we need actually to have another steering mechanisms for that. Yes, it's more complex, but think about humanity. It's the only intelligence that is sophisticated and advanced enough that we can discuss that we are trying to build something similar to. And if you're looking at you as an agent, your brain is a compounded system first. Not all the data is going through the same component in the brain. There are multiple components and for different tasks. And that's the way that it's working. And it can be almost guaranteed statistically that if you have 5 components, that each one of them is experts in all the tasks that you have, it will be at least as good as one component that is good in all the tasks. The reality is that it's much better to do that because we are not familiar with one component that is good in data pooling and knowledge preservation and planning and reasoning and steering and personalization and emotional things, etc. We are not familiar with this one component, and it's not transformer-based systems. It always will be faster to get to intelligence with multi-component system because each one of them can be better in other things. So this is like from the one compounded agent. And the second thing is a multi-agent system. Like in humanity, you're not good, you're not the best in everything in the world. There are other people better than you in something, and you are better than them in something. But if you will use them in that part, if you have access, first of all, to all of them, and you'll be able to utilize them in order to achieve your task, you'll perform better in this specific task. And this is why single agent systems are shown and show a lot of promise to show demos. Think about your family doctor and you'll go and say, I need brain surgery currently. And so like, yeah, sure, let's come. I will do it for you. And so no, I want an expert in that part. I don't want you to do that. You don't want because he doesn't know how to do it and he doesn't have the experience in order to do that. In the same thing, the single agent system, like ChatGPT, for example, or any other like Gemini or other systems that we are familiar with today are good in doing everything, but they are almost not good in anything they are doing. Not enough. They are good in, as we said, because of the large language model to fix text, to phrase it, etc. But we are barely seeing enterprise use cases besides content generation, probably, that the current systems are doing. And we are hearing from the executives, it was amazing the way that they did it. We don't need any more like X, Y, Z, W, or we can do a lot more. Usually it's nice for demos, but for the real world examples, it's not good enough. And this is actually something that a multi-agent system can solve. Again, humans are working in a similar way. We are trying to get as close as possible to the way we are working, both as individuals and as a community, because again, that's the only really good example that we have that is actually working. So this is like the way that we are trying to get also the agents ecosystem plus the human ecosystem to work together.
Yeah, that makes sense to me. And I think when you're building a team of any kind, or even as you're working within your own home, I know that I'm not a great plumber, right? But I still have to know that about myself. And then I would contact someone who is an expert in plumbing because I have a need for that. Understanding how we bring a
And
team
this
together,
mechanism,
which
by the way, that you have to decide that you're not good at it is crucial in order for you to be able to achieve the task. Because if you don't have it, you'll do a pretty bad job because you're not good at it. So
it's bad. I've done enough bad plumbing jobs to know that I'm not good at plumbing.
Yeah, but this is actually one of the components that is missing today in the technology that we and also some others are working to complete in the system, and it's not a generative AI module in that part. It's a different technology.
But that applies though to, I think of just organizations in general understand that concept because there are different roles that they fill within the organization with people who have specific skill sets. So the same thing would apply, I would expect, going into building an ecosystem for an AI or a multi-agent system where you have expert activities for natural language processing, for visual understanding. So those would be components that would be necessary for that particular ecosystem and the tasks that it's being assigned or to do. I think the model is already there. Companies understand they have different roles and do that. When you start looking at this going forward, do you think that same concept will be applied for that ecosystem that we're currently seeing for our job roles that we fill with people right now?
Yeah, I think so. I think that we'll get to a situation that will hire agents eventually that has specific expertise that learn actually from specific places. We'll need to see how we are separating the company and enterprise knowledge in the future from what they learn, right? If you worked at Google and Amazon and Facebook, all of them maybe are competing, but you didn't take the data, but you took something with you. The agents can do the same, right? They can take the personality experiences that they learn in different interactions they had, and they can have, compared to you and us, hundreds of millions of interactions like that, because you can scale them very easily. And they can take those with them in order to get more, to have better expertise in what they're doing. And yeah, I believe that you'll be able to hire, again, agents that are expert in specific things, maybe also in different prices in the future. We are not there yet, but yes, an agent that is better in marketing can cost more than the agent that just like doing it, that has like 1 million interaction compared to an agent that has 500 million interaction and learn more things, and we're able to get more experiences on what is working, etc. The same manner that you will pay differently for a junior, or if you're hiring a C-level from Google currently. So you'll pay
Makes sense.
differently in that part. We believe that we'll have similar interactions with agents. It will be much, much, much cheaper. And that's one of the things that we'll be able to see in the productivity gains. We'll be able to have experts in a lot of different tasks that we are able to hire in dozens or hundreds of bucks a month compared to tens of thousands of dollars a month. And they are working also 100 or 1,000x faster. Combine it together and you're getting to productivity gains and cost efficiency that can change the whole industry completely.
So I want to end on that because I think this is a really good question. What excites you most as you start looking into your crystal ball going out, the next 12 months even? Because I know it's difficult to see beyond that, but the next 12 months or so, what
Yeah.
excites you the most about the developments that either you're putting together or that you've seen in the general market space?
Some people are saying that it's very difficult to see 1 month forward currently. But if I'm looking like actually even a bit more than like a year, I think that currently most of the systems are good as co-pilot. As I said, the human is steering the system in that part. I hope that in the next year, we'll get to a situation that the steering mechanism we have at one end in general, as humanity, is good enough to run a lot more processes in an automated way, meaning that as humans will be able to give much, much higher level commands and they will get executed in an autonomous way by the agents. Each improvement like that will boost productivity from 100% gains to 500% gains. 500% gains productivity is hundreds of trillions of dollars to the economy if used and utilized properly. So I believe that to get to a steering mechanism in the AI world, the research world, and also at Wand as a company in the next 12 months that will enable us to get to significant higher level commands and prompts that we can give to the systems is something that is feasible. And this is one of the things that we are our core fundamental research group is working on in a significant capacity.
That's super exciting. I'm looking forward to see how that starts to materialize as we go over the next 12 months now. Thank you so much for talking with us today and providing your expertise and your opinions on how things are going, because you're at ground level as you're seeing these things expand and grow. And it's not because you just got exposed to them, because of your deep expertise you've had over the past 7-8 years, really building these models and applying them to business use cases. So I really appreciate your expertise as we talk through this today.
Thanks a lot, and it was a pleasure to speaking with you.
Thank you for listening to Transform Now, the podcast from SS&C Blue Prism. You can find all of our episodes on your favorite podcast channel, as well as YouTube. To stay on top of the hottest topics in the world of intelligent automation, subscribe now. The future of work is here.